All right, so this is the second FRQ on the 2013 AB calculus exam, and since it's number 2, that means we're going to use our calculator. So I went ahead and just cleared it from the last problem I did. They have the velocity. I'm going to graph this, and the reason that I'm graphing it is because if I type it perfectly now, I don't have to worry about typos later. Okay. So I'll just double check and make sure I've got it. -2 t squared plus 3t to the 6/5 minus t squared. Yep. All right, and it says from on the interval from 0 to 5. So I'm going to go ahead and set that interval. I'm going to hit the zoom button and go down to 0. That's going to make the window fit for that domain that I chose from 0 to 5. Sometimes it does a great job. Sometimes, like here, I'm not loving this. You can see it's doing it. It made the window that big because it wanted to show this part down here. But what I'm going to do is make my window zoom in a little bit more because it's typically the stuff right around the x-axis that we were most interested in. So I'm going to change this between like -10 and 5. Okay. So the first question says, find all values on the interval from 2 to 4, where the speed of the particle is 2. So we know that speed is the absolute value of the velocity. So I already have the equation plugged in as just regular velocity. I could go back and for y2 plug in the absolute value of velocity. And if you have a color computer or a color calculator, I would actually probably do that because those are pretty easy to hop back and forth between. But with this calculator, it's not very easy, so I'm just going to leave it like that. So for this calculator, instead of plugging in an absolute value, I'm just going to check to see where it equals +2 and check to see where it equals -2. Before I go any further, though, I'm going to change my window to 2 to 4 because they didn't want me to look at anything else. All right, so second trace, option number 5. .128. And then I'll do it again with -2. Okay, so there are 2 values when the speed is 2. Looks like one's in the positive direction and one's in the negative direction. All right, next says to write an expression involving an integral that gives the position, s of t, and then use this expression to find the position of the particle at 5. So we're going to have to use that s of 0 equals 10 that was given in the problem. So I'm going to say s of 0 plus the integral from 0 to whatever time you want. Doesn't matter. That's because here we're writing an expression that'll give us s of t no matter what the t value is. So this is using, now I can't say v of t. I have to have a different variable. Okay, so if you want to know what the position is at t equals 5, then you're going to say, okay, take that initial value and the integral from 0 to 5. And that's going to give you s of 5. Okay, so go back in here. I've got 10 plus the integral from 0 to 5, and then I'm using the velocity function that I have plugged into my calculator. So s of 5 is -9.207. All right, find all the times in the interval at which the particle changes direction. So here we want to know not only where the velocity equals 0, but we want to make sure that it switches from positive to negative on that interval. So I'm going to go back. I'm going to make this from 0 to 5 again. Okay, and it looks like, oh, I forgot to take the -2 out. Actually, I'll go ahead and plug 0 in there, and then I can just do intersect again. So there's our graph. I can't see it, but right now it's graphing that y equals 0 horizontal line. So now I can do second trace, option number 5, enter, enter, enter. Okay, so it found the second one first. And so now I'll do the same thing again, and I'm just gonna scroll over, and I just want it to be closer to that first one. And it says to justify your answer, and so the justification is that the velocity changes signs. All right, and then last question, is the speed of the particle increasing or decreasing at t equals 4? So first I'm going to say what the velocity at 4 is, then I'm going to find the derivative of velocity, which is the acceleration at 4, and I'm going to compare the signs. So I've got my velocity at 4 is -11.476, which is less than 0. And then I've got math 8. So there's my derivative at 4, -22. Which is less than 0. And so we're going to say the speed is increasing at time t equals 4. And the reason is because the velocity and acceleration have the same sign.